Here we're going to look at the last two questions of the kinematics, 5 and 6, the last two examples. Question 5. A particle is moving in a straight horizontal line with constant deceleration 4 meters per second squared. At time t equals 0, the particle passes through a point O with speed 13 meters per second, travelling towards a point A where OA is 20 meters. Find the times when the particle passes through A. It says time, so I'm expecting 2 there at least, and the value of t when the particle returns to O. So let's have a look. Let's get our diagram drawn. So it's moving in a straight horizontal line. Okay, and that's important. And these questions will always be like that. So we'll go from left to right again. So let's make this our positive direction. So here's our particle moving along the straight line. And it's decelerating at 4 meters per second squared. So it's going in this direction, but because it's decelerating, it's slowing down, so the acceleration is in the opposite direction. So the acceleration, to indicate it's going in the opposite direction, we make it minus 4 meters per second squared. Minus just means direction, so although it's traveling from left to right here, it's actually going to be slowing down, and eventually it's going to stop and have 0 velocity. And then if the acceleration carries on, because the acceleration is to the left, it's going to start going back to the left. At time t equals 0, the particle passes through a point O. So at time t equals 0, let's call this point O. So that's at time t equals 0. Okay, and it's got a speed of, it's going this way, and it's got a speed of 13 meters per second. Traveling towards a point A. So eventually it's going to reach A. And the distance there is 20 meters O to A. A bit more going on in this question. Okay, I'm not going to call that S, I'm not going to call it a displacement, because it's just a distance for now. So find the times when the particle passes through A. Okay, so if we treat O as the initial point, then A is 20 meters away, so the displacement, it's at A when the displacement of the particle is 20. So what we're expecting to happen here is that the particle is kind of coming this way, it gets through, it hits O at this point, we're calling that time 0, U is 13. It's going to carry on, but remember it's decelerating, so we're expecting it's going to go past A, decelerating, eventually it's going to stop, and then because it's accelerating this way, it's going to start going back, and it's going to go back through A again. So there'll be 2 times where that happens. The time where it's going from left to right through A, then it goes past A, and then it's going to start coming back eventually, and it's going to go back through A again. So let's have a look at how this is going to work in our equations. So we have U is 13 meters per second, and we have the acceleration is constant, it's minus 4. And we know that the displacement when it's at A, so with the time when it'll be at A, the displacement will be 20 meters from its initial start. And we're looking for t, we don't know what t is. So we want to find the formula linking these variables, so we're looking for s equals ut plus a half at squared. And you'll notice that this is a quadratic in t, there's a t squared here. So when you're solving this kind of equation, you can potentially get 2 times, which is good, it's what we're expecting, because we expect the particle to go through A, carry on, stop, and then start coming back through A in the opposite direction, because if the acceleration continues, it's going to keep accelerating left, eventually it's going to stop going to the right, and it's going to start going back left again. S is 20, U is 13, we don't know t, plus a half, A is minus 4, and t squared we don't know t, but we can solve this to quadratic in t, so let's just tidy it up. Half times minus 4 is minus 2, get the t squared positive, so it's a bit easier to solve, so add 2t squared minus 13t, and that 20, just there it is. And either you can use your formula, or I think this one factorizes. So we'll have 2t and t, factor of 20. If you want to try and do it yourself, you could pause it first, but there it is. So we get 2t squared minus 8t minus 5t gives us the minus 13t. Minus 5 times minus 4 gives us plus 20. So we get 2t minus 5 is 0, or t minus 4 equals 0. So t equals 4 seconds, or t equals 2.5. Normally I'd write this as an improper fraction. Because we're kind of dealing with time and distance, decimals make a little bit more sense. So there's 2 times where it passes through A. It's going to come from the left, it's going to go through O, and then after 20 meters and 2.5 seconds it'll pass through A going from left to right. It's a terrible arrow, sorry. And then it's going to keep decelerating, and eventually it's going to stop somewhere past A, and then if the acceleration carries on to the left, it's going to go back towards A, and then it's going to go back through A, and that will happen after 4 seconds in total from time t equals 0. And then part B, I'll do alongside this time. So part B. The values of t when the particle returns to O. Okay, so if the particle returns to O, that's when the time is back here again. Okay, time t equals 0. We know that's when it starts at O, but we know that it's slowing down. It's going to go through A and stop. It's going to go back through A, and then it's going to carry on back through O again. There's a couple of ways of doing this one. So if time t equals 0 is when it's at O, the displacement from O will be 0. So I can look at when s is 0. Okay, yeah, the particle is going to be travelling. Obviously, it will have travelled through A, past A, come back through A, and back to O. So it will travel quite a long way distance-wise, but displacement-wise, from O, it's not gone anywhere if it's at O. Okay, so one of those times will be when it's 0, and the other one will be the time when it's kind of coming back through O again. Okay, and that's what we're looking for here. But the displacement will be 0 because the displacement we're dealing with is from O. We know our initial speed at O when it first comes through O is 13, and we know A is minus 4 still. It's at the top there. And we're looking for t again. So in part A, we're looking at the time when the particle is going through A and back through A. But in similar fashion, we can show that there's a time when the particle goes through O is 0, and also that it's going to go past O, through A, and then come back again and go back through O again. And that's when its displacement from O is 0 again. So again, the formula in these variables is the same one. S equals ut plus a half at squared. Sub in, s is 0, u is 13, we don't know t, a half minus 4 t squared. Tidy it up. So we get half times minus 4 is minus 2. I'll get it positive. So 2t squared minus 13t is 0. Factorize t out, and you get 2t minus 13. So we get t is 0, which is what we expected, because obviously that's the initial thing. It's not gone anywhere from O. Okay, and that was what we've already got in the diagram when u is 13 that way. Or 2t minus 13 is 0, so t equals 13 over 2, or t equals 6.5, or 6.5 seconds. Okay, which makes sense. Obviously, if our time here was less than that, it wouldn't make any sense. Okay, and this is time after it passes through O initially. Because it's going to go through A, it's going to go through A at 2.5, we work that out, it's going to go past A, stop, it's going to come back through A, and that will happen after 4 seconds in total. So to reach O, it's got to go another 20 meters, so it's going to be a little bit further, and that'll be 6.5 seconds. Okay, and we'll just highlight, because we've got 2 values of here, we'll just highlight, therefore, particle returns to O. .5 seconds after it first passes through O. And that's question 5. Question 6. I'll draw this out at the same time as reading it to save some time. So particle P is moving on the x-axis with constant deceleration. So again, horizontal line, positive direction, left to right, and it's got a constant deceleration. Let's get rid of the ruler for now. So positive direction, left to right. It's decelerating again, so left to right is the positive direction, so this will be minus 2.5. Decelerating means acceleration is going from right to left. Minus takes that into account. And we've got our particle P. At time t equals 0, so it passes through the origin O. And so I'll just call this O actually. So this is time t equals 0. Moving the positive direction of x, so left to right, and its speed, so u, or initial speed, is 15 meters per second. Find the time between this when P first passes through and this when it returns to us. So very similar to the last question that we just did. When it's at O, time is 0, and the displacement will be 0 from O as well. But obviously the particle is going to come through left to right. It's going to come through this way. It's going to reach O. We're calling that time t 0. It's decelerating, getting slow. Eventually it's going to stop, and it's going to come back this way, and it's going to go back through after a particular time. So let's write our details down. So we know that u is 15. We know that a is minus 2.5. And we know the displacement will be 0 when it's at O. And we're looking for the time. So again, s equals ut plus a half at squared. Sub in s is 0. 15 is u, 15t. Plus a half a minus 2.5 and t squared, we don't know t, quadratic in t, so 15t, sorry, we'll keep it all as it is, so 0 equals 15t, this will be minus, what am I talking about, not minus 5, minus 1.25, t squared, get the t squared positive. Factorize out your t. A little bit ugly because it's a decimal, but because it's quite an easy factorization, it's fine. So we get t equals 0, which is what we expect. We know that in the question. T equals 0 here. And also we get 1.25t minus 15 is 0. And if we rearrange this, then we get t equals 12 seconds. So particle returns to O at t equals 12 seconds. Part B, the total distance travelled by P during this time. So the total distance travelled, we want to find what happens when eventually P, the particle goes through, it carries on, eventually it's going to stop and it's going to return to, and this is really important, this comes into play when we do gravity as well. When it stops, because it's obviously it starts going from left to right, and it's decelerating, acceleration is from right to left. Eventually it's going to stop. When it stops, the velocity of the particle will be 0. That's what happens when it stops, and then it's going to start going back towards O. But that's really important because now I can work out this distance here, the displacement from O. And obviously to get back to O, it's got to travel that same distance again. So we can now use u is 15, we've got v is 0, that's the end of the line for it, a is minus 2.5, and we can try and find s. So v squared equals u squared plus 2as, v is 0, 15 squared plus 2as. So this is 225 minus 5s, rearrange, divide by 5, so this is going to be 45 meters, but that's the displacement when v is at its very final point here on the right. So therefore the total distance travelled by P in that time from starting at O and then getting back to O is going to be 2 lots of that. So it's going to be 90 meters as my final answer, because it's got to go there and it's got to go back.